Okay guys, welcome again. Today I'm going to be tackling the CyberChef, the basics. I'm almost done with this Cybersecurity 101 learning path. I'm currently here, so we only have like three, four, five, six modules left. So let's get to it. Okay, so this room is an introduction to CyberChef, the Swiss Army knife for cybersecurity professionals. Okay. So introduction. CyberChef is a simple, intuitive web-based application designed to help with various cyber operation tasks within your web browser. Think of it as a Swiss Army knife for data, like having a toolbox of different tools designed to do a specific task. These tasks range from simple encodings like XOR or base64 to complex operations like AES encryption or RSA encryption. CyberChef operates on recipes, a series of operations executed in order. Okay, so you can see cooking. Okay, Morse code, blah blah blah. Okay, learning objectives. Learn what CyberChef is. Learn how to navigate the interface, understand common operations, and learn how to create recipes and process data. XOR, base64, base85, extract IP address. So I guess these are all the things that CyberChef is able to do. So room prerequisites: familiarity with the following rooms is recommended, but it is not mandatory before starting this room. Hashing basics and cryptography basics, which are rooms I have already completed. So then accessing the tool. There are different ways to access and run CyberChef. Let's check the two most convenient methods. Online access. All you need is a web browser and an internet connection. Then you can click this link to open CyberChef directly within your web browser, which is what we have just done here. Okay, yeah, I've used this tool before. Okay, so offline or local copy. You can run this offline or locally on your machine by downloading the latest release file from this particular link, which is a GitHub. Let's just copy and paste this because I want to add this to my cybersecurity pen testing tools. I've been doing that on my GitHub. So, okay, CyberChef. Let's add it. Yeah. Okay. So let's keep going. Yeah. Okay. So this can also be used offline, right? This will work on both Windows and Linux platforms. As best practice, you should download the most stable version. I have access to CyberChef and I am ready to dive into it. Okay. Okay, let's keep going. I was just reading the GitHub on how I would be able to run this offline. I think I would be using containers for this, like Docker. Then, yeah, I was just reading through it. Okay, but let's get to it. Navigating the interface. Okay, CyberChef consists of 4 areas. Each consists of different components or features. These are the following areas: operations, recipe, input, and output. So these are the operations, right? All of this. And then we have also the recipe, which is this one here, the input and output. Okay, we can see all of them. Let's discuss each of these areas below. The operations area. This is a practical and comprehensive repository of all the diverse operations that CyberChef is equipped to perform. These operations are meticulously categorized, offering users convenient access to various capabilities. Users can utilize the search feature to locate specific operations quickly, enhancing their efficiency and productivity. Below are some operations you might use throughout your cybersecurity journey. From Morse code, okay, translates Morse code into uppercase alphanumeric characters, okay, becomes stressed when used with default parameters. Then URL encodes problematic characters into percent encoding, a format supported by URIs and URLs. Yeah, I've used this before, becomes this, okay, when used with the parameter encode all special charts, okay, and then to base64, to this operation goes raw data into an ASCII base64 string, this is fun, then base64 string, okay, and then to hex, converts the input string to hexadecimal bytes separated by the specified delimiter, okay, this becomes this, okay, to decimal converts the input data to an ordinary integer array, the decimal conversion is awesome, becomes this. And then route 13, a simple Caesar substitution cipher which rotates alphabet characters by the specified amount. Default is 13. Digital forensics and incident response becomes this. Right? Alternatively, you can directly check how the operations were by hovering on the specific operation. This should give you a sample or a description and a link to Wikipedia. Okay, the recipe area. This is considered as the heart of the tool. In this area, you can seamlessly select, arrange, and fine-tune operations to suit your needs. This is where you take control, defining each operation's arguments and options precisely and purposefully. The recipe area is a designated space to select and arrange specific operations and then define their respective arguments and options to customize their behavior further. In the recipe area, you can track the operations you want to use and specify arguments and options. Features include the following: save recipe. This feature allows the user to save selected operations. Then load recipe allows the user to load previously saved recipes. And then clear recipe. This feature will enable users to clear the chosen recipe during usage. This can be found in the highlighted icons below. Okay, so the bottom part of the image above is the bake button. This processes the data with the given recipe. Additionally, you can tick the auto bake checkbox. This feature allows users to automatically cook using the selected recipe without manually clicking bake every time. So the input area. This input area provides a user-friendly space where you can easily input text or files by pasting, typing, or dragging them to perform operations. Additionally, it has the following features: add a new input tab. So this is where an additional tab is created for the user to use different values from the previous tab. Yeah, add a new input tab. Okay, then we have multiple tabs. Yeah, and then open folder as input. So this feature allows users to upload a whole folder as input value. And then open file as input. The same with the file. Clear input and output. Okay, this feature allows the user to clear any input values inserted in the corresponding output value, right? Reset pane layout. This feature brings the tools interface to its default window sizes. Output area. So the output area is a visual space that showcases the data processing results. It neatly presents the outcomes of any manipulations or transformations you have applied to the input data, allowing for a clear and intuitive display of the processed information. So the features include save output to file, then copy raw output to the clipboard, replace input with output, and then maximize output pane. Okay. In which area can you find from base 64? That would be in the operations, right? Operations. And then which area is considered the heart of the tool? That would be the bake, what was it? Recipe. Yeah, so before anything else, okay, hold your horses. Before even going to the actual thing, let's have a quick overview of the thought process when using CyberChef. This process consists of 4 different steps. Step 1, set a clear objective. Step 2, put your data into the input area. Step 3, select the operations you might want to use. Step 4, check the output to see if it is the intended result. Hence, repeat the process either from step 1 or 3. Okay, let's discuss each step further. Setting a clear objective is essential. This step involves defining specific and achievable goals. It helps answer the question, what do I want to accomplish? Objectives are vital in providing direction, purpose, and focus to your goals. One example would be, during a security investigation, I found a gibberish string. I want to know what hidden message it contains, if it has one. Next, put your data into the input area. In this step, you use your data. That is where you paste or upload the gibberish string that you found. The third step is to select the operations you want to use. This can be tricky if you're not familiar yet with what you are dealing with. Following our example, we are still determining what to use to understand this gibberish string. During our research, we found relevant information that this gibberish string might be using anything related to encryption. Therefore, we decide to use any operation under the encryption or encoding category, including but not limited to ROT13, base 64, base 85, or ROT47. Note that we can use a lot of operations under this category. Lastly, check the output to see if it is the intended result. This begs the question, have we achieved our objective? In our example, it would mean were we able to decode the gibberish string we found? If yes, then that's it. If not, we may need to repeat the steps that we have taken. To provide visual clarity to our example, see the figure below. So the step 1 is during a security investigation, I found a gibberish string. I want to know what hidden message it contains, if it has one. And then the next step, step 2, is paste or upload the gibberish string that you found. Step 3 is determine through research what to use to understand this gibberish string. Use any operations under any category that might be relevant. And then the step 4, were we able to decode the gibberish string we found? Yes, no further action. No, repeat the process either from step 1 or 3. At which step would you determine what do I want to accomplish? Step 1. What? Oh, well. Yeah. And then the next one is practice, practice, practice. Let's download the task files. Extractor. Yeah, sure. What I'm gonna do now is CDCDF, TryHackMe. What am I? Okay, now I wanna make here CyberChef the basics. CyberChef the basics, and then I wanna move whatever I have here Downloaded, what was the name of this file? Extractor. And I want to move it here. No, I should have it here. Okay, we want you to be as prepared as possible. Therefore, we will explore some of these tasks, most commonly used operation categories. Recognizing which category to utilize can enhance your ability to use the tool more efficiently and effectively. So the extractors. The specific operations mentioned in the table below fall under the extractors category. A specific extract IP addresses, extract all IPv4 and IPv6 addresses, extract URLs, extract uniform resource locators from the input. The protocol HTTP FTP is required, otherwise there will be far too many false positives. Extract email addresses, extract all email addresses from the input, and then the extract IP addresses will extract any valid IP. Extract email addresses the same for any particular email, any strings characters with this format, right? Domain, okay, examples, hotmail, blah blah blah. Extract URLs, extract uniform resource locator, commonly known as URL. URL is the address used to access resources on the internet. You can check the web application basics room if you would like to dig deeper into URLs on web applications. The date and time. The specific operations in the table below fall under the date and time category. From Unix timestamp, converts a Unix timestamp to a datetime string, and then to Unix timestamp, parses a datetime string in UTC, and returns the corresponding Unix timestamp. A Unix timestamp is a 32-bit value representing the number of seconds since January 1st, 1970 UTC, the Unix epoch, to convert Friday, September 6th, 2022, and then this amount of I don't know, milliseconds, I would guess, plus 4, 2024, into a Unix timestamp. Use the operations to Unix timestamp, where the result would be this particular here. Okay, from Unix timestamp. Okay, if you wish to convert back to a more readable format, you can use from Unix timestamp. Okay, so date format. The specific operations in the table below fall under the data format category. Okay, so from base 64, this operation decodes data from an ASCII base 64 string back into its raw format. So this becomes welcome to TryHackMe, and then URL encode or decode, right? Converts URI or URL percent encoding characters back to the raw values. Becomes this, okay. From base 85, notation for encoding arbitrary byte data. It is usually more efficient than base 64. This operation decodes data from an ASCII string with an alphabet of your choosing, presets included. Okay, becomes hello world, okay. From base 58 is a notation for encoding arbitrary byte data. It differs from base 64. How so? By removing efficiently misread characters like, okay, LLO or 0 and O to improve human readability. Okay, so this becomes this. Okay, to base 62 is a notation for encoding arbitrary byte data using a restricted set of symbols that humans can conveniently use and process by computers. The high number base results in shorter strings than with the decimal or hexadecimal system. Operations such as base 64, 85, 58, 62 are known as base encodings. Base encodings takes binary data, strings of zeros and ones, and transforms it into a text-based representation using a specific set of ASCII, American Standard Code for Information Interchange characters. Although we have a dedicated room for hashing basics, let's have a quick overview and discuss the most commonly used operation, base 64, right? For example, would be to encode the letters THM. We have a short ASCII table here that we can use for reference. If you want to view the complete ASCII table, please refer to this page here. Okay. Okay. Decimal binary symbol, and then same for this. Okay. So step one, convert to binary and merge manually. Okay, based on our table above, T equals to this binary, and then H equals to another, and M, okay, THM. Next, concatenate these binaries and make sure they have 24 characters. You should have this. Yeah, okay. Divide and convert to decimal manually. Separate this into 6 characters each. You should have this, right? These are 6-bit characters. We should have four instances of this now. We need to convert each instance to decimal. Let's convert them. So this from binary decimal to base 10 would be 21, 433, 13. And then convert to base 64 manually. Now that we have the numbers, from the previous step, which are 20, 21, 433, and 13, let's look at for the equivalent characters from our table below. This table represents a base 64 index table. Okay, upon checking from the table, we should have found its corresponding characters by now. Okay, 21V. Yeah, makes sense. Combine these characters and you should have the equivalent of THM in base64 format. The answer would be this. Oh wow, isn't that amazing? You just converted a set of characters into base64 manually. Now let's discuss the URL decode. This works by converting the percentage encoded characters back to the raw values. For reference of these values, you can check the page here. Note that the full character set in HTML5 is UTF-8. Check the table below for a quick overview of what we can typically see in our URL, which is the case, right? Characters this, equivalents from UTF-8, and then also this to F to E. Yeah, okay, 23. Then practical exercise. Click on the Load Task Files button on the top of this task to download the file that we will use to answer the questions below. Once downloaded, you can open the file, copy and paste the content into the input field, or use the Open Files input feature to upload the file. Okay, let's check it out. Okay. So what if I go about editing it? Just copy the content. What is a hidden email address? Okay, so we're gonna put this here. What? Okay. No, but I should be able to copy. What happened? Janked. Yeah. Okay. Has been detected. Okay, so what is the hidden email address? Well, email. Extract email addresses. Now we put that in the recipe, and then we have this email address, hidden email, right? Hidden. What if I just look for that? What if I just look for that? Oh, we found it as well here. Okay, I just wanted to check that out. So it will be hidden at email address. What was it? Hotmail.com. Hidden at the Hotmail.com. Okay, so what is the hidden IP address that ends with 232? So let's use this tool, yeah, right? So what are we extracting here? We're extracting the hidden IP. So with the IP, change parse group, extract IP addresses. So we want this, we can just throw away. How do I do that? Okay. And now we have these two IP addresses. And what they're asking me is what is the hidden IP that ends with 232? It's this one. So we copy and paste it. And then which domain address starts with the letter T? Domain address. Okay, we also have to extract domain, extract domains. Now this we remove, then bake, and then we get domain address that starts with the letter T would be tryhackme.com. And then what is the binary value of the decimal number 78? The binary value of the decimal number 78. Okay, so we can remove all this. Then we put it here, and then we're converting this to decimal, right? To decimal. No, binary. To binary. Okay, so the binary value would be this. What is the binary value of the decimal number 78? This is the binary. But wait, why do I have two values here? From, okay, no, I think from decimal to binary, right? And that's the answer we were looking for. Okay. Now, what is the URL encoded value of? So you want me to encode this, okay? So let's remove it. Let's remove this. Let's copy the input, and then you want URL encode, right? URL encode. Encode all the special chars, and this is the value, right? Yes. Okay, so your first official code. This task allows us to apply what we have learned from the previous task We'll utilize CyberChef's areas and its features to answer the questions being asked. Now, this is the time that you truly shine. You're going for your first cook ever. Your turn to cook. Okay, ready? Let's get our hands dirty then. It's best to try to answer the questions first without using the hints. Yeah, of course. Using the file you downloaded in task 5. Which IP starts with the 10? Oh, okay. Starts with 10. This one. 10, 10 to 10. 10, 10 to 10. Okay, what is the base 64 encoded value of the string nice run? So the base 64 encoded value. So this is the string, and we want to base 64 encoding to base 64, right? And the base 64 encoded value of that would be this. And then what is the URL decoded value? Okay, so we want to decode this particular URL. Let's do it. Let's copy paste and then decode URL decode. Yeah, and then this is it. Okay, and then what is the datetime string for the Unix timestamp? Okay, datetime string. Okay, so this is the input, and then you're asking me the datetime. Date time delta to Unix. No, from for the Unix, from Unix, right? From Unix, and this is the one. Okay, now what is the base 85 decoded string of the value? This base 85. Okay, so move this base 85 from base 85. What you do? No, this is fun. Yeah, and easy, right? Fun and easy. So that's the tool we have. In this room, we discuss how CyberChef is a powerful tool for handling various data transformations and decoding tasks. Whether you need to work with base 64 binary or URLs, this digital wizard's kitchen provides a visual interface that makes data manipulation intuitive and straightforward. With a diverse recipe library, you can confidently tackle tasks ranging from extracting email addresses, IP addresses, and domains. We were able to navigate this interface and have a high-level discussion of the different areas, features, and parameters. However, note that for particularly large-scale processing, it's vital to benefit from support from other tools, right? I will have CyberChef, the Swiss Army knife of cybersecurity, ready for my upcoming journeys, that's for sure. So that's it for today, guys. This was the module CyberChef, the basics. We tackled all the practice scenarios here, and yeah, we are ready to move on to the next, right? I feel like I'm slowly getting back to my previous I don't know, hacker capabilities, let's say, because I haven't been doing pen testing or CTFs for few months because I was focusing on building web applications. But then, yeah, you know, like the song says, I feel it coming. Yeah, you know, so the powers are coming back to me because I'm remembering all these tools. I'm also taking notes of some things that I'm going learning. So yeah, that's it for today, guys. Thanks for staying up with me. Uh, until I'll see you in the next module that we will tackle from TryHackMe. Oh yeah, and also do know that I will be going through all these learning path, web application pen testing, which is an intermediate difficulty level. I'm excited to go through this and just basically get the certificate as soon as I can. So that's it for today, guys. Thanks for sticking up with me. Peace. Always learn.